All right, polar coordinates are different from rectangular coordinates. We have always used rectangular coordinates, like you go over left or right so much, and then you go up or down so much. You learned them in, like, I don't know, 4th, 5th grade is the first time. You probably just did positive, positive, but remember doing coordinates, okay? Everything in the rectangular coordinate plane has one single name. In other words, if I handed you all a sheet of graph paper and said graph the point 1, 7, and it already had the X and Y axis on it, everybody would graph it at the same place, yes? Okay. Every point has a single name. That's not true in the polar coordinate system. But there is still a point that we're going to kind of call the origin. It has a different name in the polar system. It's called the pole, like the North Pole or something. I don't know. And then it also, we're not going to have an X and Y axis anymore, but we're still going to have a line to start from, which is in the same place as the X axis. So it says a polar coordinate system, the origin is a fixed point, which is still here, called the pole. I'm just going to call it the origin still, probably, because that's what I always call it. The polar axis is an initial ray coming out from there, usually horizontal and directed toward the right, which would mean it's the same spot as the x-axis, yes? Positive x-axis, okay? They call it the polar axis, positive x-axis, same place. The location of a point, ooh, this is new, is going to be r theta, not xy anymore. Okay, hang on. Yay. Okay, come on. So everything is now going to be named, the ordered pair is not any longer an x and a y, it's going to be an r and a theta. Theta is going to be an angle, it's going to rotate around. R is going to be a radius, because our graph paper is going to look like this. Look, guys, this is the graph paper. So this little circle in here is a radius of 1. This one out here went out 2 units to a radius of 2. Do you see what I'm talking about? Okay. So R is going to tell us the radius or distance out that we measured. And theta is going to tell us the directed angle or the amount of turn. Now, if we turn this way, it's going to be positive. If we turn this way, it's going to be negative. Same thing we've always done. All right. So we're going to do a whole bunch of practicing on this polar graph paper. I did fail to read you this sentence. I do want you to know that air traffic controllers, they use this kind of a system. All kinds of radar, yes. Does that kind of look like a radar screen? Anybody play video games or they have anything that looks like that kind of thing? Okay. So I don't know how, your video games necessarily do it, but I think radar traffic controllers probably use off of north instead of off the positive x-axis. I'm not really sure. But the two things they do is they have an amount of turn and they have a distance from the center. So when we go to do this point, 3 and pi over 4, what we're going to do is we're going to rotate in the positive direction to the pi over 4 line, which isn't labeled on this one. But is everybody okay that it's 45 degrees, so it's halfway to here and all that good stuff? You can have out your unit circle sheet. It might help some of you because they're not all labeled. The other thing is you can use the unit circle sheet on basically any quiz this semester. So if you want to have it out when you're doing this quiz, it's fine. This 3 means you go out from the center 3. Now, this paper has like a white spot in the middle, because if they draw all these little lines in, it gets really hard to see. But this is a radius of 1 right here. Do you see what I'm talking about? So this is a radius of 2, and this line is a radius of 3. So P is right here. Went around pi over 4 and out to the radius of 3, and that's where they plotted point P. Not too hard. Oh, just kidding. Okay. This we should understand. We're good with negative degrees, yes? So we're going to go around 120 this way, which is the 240 line. Does that sound okay? Now, this is new. We've never had an R that was negative before. We said R couldn't be negative when we were drawing our little triangles. An R that's negative means instead of going out 2.5, you're walking backwards. You're going to go this other direction on the opposite ray if you're using geometry terms. You're going to back up 2.5 circles back into the opposite quadrant. Now, I don't like this picture very much. What this actually would look like, guys, they made it look like there's a line, all this crazy business. You would rotate around to 240, and then you would back up 1, 2.5. It would be like right there. And that's point Q, okay? The line is just a guideline. It's not part of the graph. I just want to clarify. All right, so that was kind of crazy. Here's another positive, positive. This one would be pretty easy. Now, they did it without graph paper. They said you'd rotate 45 and you'd go out exactly 2. Here's one with a negative. This one has a positive angle. You would rotate around 2 pi over 3. Everybody see that on your unit circle? 2 pi over 3 is over here, right? But what does the negative make us do? Go backwards. So we'd still wind up over here. If this was 1 circle, 2 circles, we'd add up 1.5 units out in that 4th quadrant. I'm thinking they don't use the words really quadrant anymore because it's not you're not split into 4 pieces, it's circles, right? But it gives the right idea to us. All right, what's this one going to do? Yep, go down or around that way 30, and then you just go out 3. You don't have to back up. All right, so help me describe for me what I would do to graph this. You don't think you have this question yet. We're getting to the ones on your paper. Good, so up here to pi over 2, but then do what? Yeah, it would be down here actually. Now, I want to talk about this. If you had the graph paper here, it would have a circle here, and this is the point you would label D. For the first time, everything has multiple names. Before I go anywhere else, can anybody give me some more names for that point? How else could you've directed me to get to that same spot? Okay, 0 would not be good because 0 means it has a radius of 0. Negative pi over 2 with a positive 1, would that work, guys? The same spot? So you went this way pi over 2 and then out 1? Okay, that's good. We'll just stick with one name for the moment. We're going to talk about eventually how you have to have lots of names. All right, this one is a positive positive, so they went around 240. That's in this quadrant, right? 240 would have had a line out here somewhere. And then 2.5, well, let me make some circles here. 2.5 would be a radius 1, 2, 2.5. So in here somewhere would have been point E. Okay. Anybody tell me another name for that point? Instead of going 240 this way, I could have gone negative 120 and out 2.5. Anybody think up another one? If you went back, what is the opposite side of 240 over here? 60, right? Because you subtract 180. Does that make sense, guys? Because it's a straight line. It's an opposite ray, so you'd subtract 180. So you could have said I went 60 degrees around and negative 2.5. Anybody come up with a negative for that one? What if I started here and went all the way around to here? Anybody confident? Negative 300, right? Because it was the same spot as 60, yes? 60 and negative 300 would be the same? Okay, that was a struggle. We'll get there. Okay. And then you have to be able to do them eventually in radians. Yeah, we can always change them to degrees and change back to radians if we need to. For this one, I just want to talk about it. 5 pi over 6 is here, but where's negative 5 pi over 6? It's the same amount this way, right? You get what I'm talking about? So then out 4 would be there. All right, we're moving on. That's more, yeah, we gotcha. Okay, do you have these? Okay, almost to the ones you're gonna do. Where is this? Anybody, what line is that on? You could add 2 pi to that to make it positive, okay? But you could also look, I just look and I go, okay, 7 pi over 6 would have taken me to the first labeled 1 past pi, right? But I was supposed to go in the negative direction to the first labeled 1 past pi. Now it said go out 1.5. 1 is this first one, half is here. I have to tell you, make sure you count this one right here where the 1 is, okay? Sometimes I forget and don't count that one for some reason. All right, this one, tell me where I would land. Negative 135. 135 is this one, right? But I went negative. But is that where I draw? A negative 2, I got to back up to, so I'm actually on the 45 line. So I could have done 245 as another name for that. All right, here we go. Easy peasy, you got this. Can you try number 1? Label it R. Is that where your point is? Around 6 to the 60 line and out 3. That one wasn't bad. Number 2 is in radians. You could add 2 pi if you didn't like the negative part of it. Otherwise, 4 pi over 3 is way down here, but I'm supposed to have gone instead of that way, this way. So what positive line is that on? 2 pi over 3 and out 4. Now, why didn't I back up? Because the first one is positive, so I went backwards, 4 pi over 3 and out 4, and that was supposed to be labeled Q. Wrong way. Negative 150 is what line? Yep, this line is negative 150 right here. But I have to do what? Go back 2.5. So what else could you name that? 2.5, 30. Okay. Anybody give it another name? Now be careful. That was the name it had. Positive. Yeah, you have to go all the way around to there, which would be negative 330 if you wanted to call it another positive 2.5. What's the other one? There's one more. We got a negative, negative, positive, negative, positive, positive. What if I went to 30? No. Oh, 210. There we go. 210 and back up 2.5, right? Now do we have them all? Negative, negative, positive, negative, negative, positive, positive, positive. Okay. Is that all the possible answers? No, because we could do it in radians. We could add 360. We could subtract 360. Okay. But those are the 4 that they're going to ask us to look for right now. This says there's multiple names. You can add and subtract 360. You can add and subtract 2 pi. But you can also change the sign from positive to negative or negative to positive if you add or subtract 1 pi. All right. I don't want to memorize any rules. I just want to think about what's going on the circle, okay? Help me with this one. It says 4 different names, but they purposefully say you can't go past 360 because you can't just add and subtract 360 to come up with your 4 other names, okay? Nice try. All right, here's one name for T. They went 135 and out 4. That's one name. It wants a total of 4, so I need 3 more. If I subtract from 360, I get I get 225, but that would have to have been a negative direction to take me to that same spot. So negative 225 and positive 4. There's one. Okay, if I went subtract 180, I'd have this would be a negative 45. And I would have to back up 4. If I'd gone all the way around to the 315 line this way, and then I still would have backed up 4. Okay. Now, we're going to try one more time with degrees, and then we got to do one in radians, okay? You have these on your notes? Okay. When it gives it in degrees, you need to answer in degrees. When it gives it in radians, you need to answer in radians. If you want to change it to degrees and then change it back, I don't care. But if you use your little unit circle sheet, I think you can do it in radians. All right, so I want to visualize. This was all the way around to 240, which is down here, right? Okay, let's just for a minute think about what's on the other side of 240. This would be 60, right? Because you subtract 180. All right, let's draw our little dot out here. It was 5 units out. So one of the answers was 5, 240. I need 3 additional ones. Okay, wait, one at a time. Sarah, you tell me what you said. What do you think, guys? If you'd gone 60 and then backed up 5, would that work? Okay, who has another one? Emerald? Okay, sorry. Okay, I think you're close. If you went negative 300, you'd be here, so you'd have to negative 5. That's good. That's a hard one to get, the negative. Basma, what you got? Okay, if we'd gone this way to instead of going around to 240, went back 120, we would go positive 5, right? Yep, that's exactly what I said. You're good. No, I'm just glad you're getting it. Everybody okay? All right, let's painfully try the radians one. Now, pi over 6 is really how many degrees? 30, so it's just right here, right? Pi over 6. And it's 2 units out. And we're gonna, it doesn't have a name, does it? Okay, well, it's 2 units out. Okay. What you got? So straight across from there was 7 pi over 6. Is that what you're telling me? And so we could back up 2. Good job. Miranda, what do you have? I need radians, though. We can do another positive 2, but we got to go all the way around. There, wait. Yes. Nope. I don't know why I had a negative on that. You're absolutely right. Yes. What do you think, guys? Is this distance right here 5 pi over 6? Right? If you had gone that way, it would have been to here. So we're going to this way, 5 pi over 6 in the negative direction. And then you would got there, you would have had to then back up 2. That's the negative. Good job, Riley. You know what? If you don't like, though, do it in degrees and then convert them to radians. You can do that, right? That's, well, you got to think a little bit. It's good to have a little thing. All right. Two more. I think there's two more basic concepts I got to teach you today, guys. A polar graph or polar equation is one that has only r's and thetas, okay? It has r's and thetas. Now, and it can have like a trig function in there too, like sine and cosine, but there's only two that you have to know for the next test or quiz. There's a basic one like r equals 4. Any guess what that's going to make? A circle whose radius is, so you'd go out 4 units, and it would be r equals 4. That's the equation of that thing. The other one you have to know and be able to recognize is this. Theta equals, and I'll make one up. What do you think that is? All points on the line pi over 4, because the radius could be anything. The radius could be 0.01, the radius could be -6, so all those points would make a line. Does that make sense? So this line, pi over 4, would be right here. Yes? Okay. So that's what you have to be able to recognize. I'm going to go to the calculator in a second. Can I not do that yet? I'll come back to the calculator fun. So r equals 2 is just a circle of radius 2. Theta equals pi over 6 would be this line at pi over 6 that goes all the way across. Doesn't stop. So r equals 3, I would have what? Circle of radius 3. Theta equals 2 pi over 3. If I did it on this graph up here, would be that line, right? Clearly drawn, nice and neat. Okay. Here, you have this one on your paper as an example, r equals 3. And this one, -60. That sounds all complicated, but it's the whole line anyway, okay? So that line has multiple names, yes? It could also be theta equals 120, theta equals 300, okay? So we got 3 of these to graph. Can you draw these and see what you get? I didn't do too bad. Is that what you got for the first one? Okay. Next one, where's 3 pi over 4? Nowhere is right. 3 pi over 4 is here. You can use your unit circle sheet. You can change it to degrees. You'll get there. And then it's a line. And -300 is the same as 60, so it's that line. So what happens is I give you the next quiz. It has a graph drawn. It's either a line or a circle, okay? And then there's 4 choices. If it was this line, the choices might be r equals 60, theta equals 60, r equals 6, and theta equals 6. I don't know. You can pick the right one? Okay. If it's a line, it's not r equals, okay? Now, that being said, this is what you can do on the calculator. When you put your calculator in polar mode in a minute, it's only going to offer you, look, can you see what this shows? It's only going to offer you r equals. So you can't draw that line at theta equals pi over 4. Just like you can't draw a vertical line on your calculator because it doesn't have an x equals button. Okay, this doesn't have a theta equals button. Now, that doesn't mean you can't. I think there's some things to do to get around that. We'll talk about that when we do more polar graphing next week. What you need to know for today, last concept. Then we'll play with the calculator, I promise. Ready? Last concept is finding the distance. This seems kind of important if you're an air traffic controller, yes? I'm going to come back. I'm going to do this one that's already done first. Air traffic controller. He has a plane at A, which is 5,310. Okay? Everybody looking up here? This plane is at A, 5,310. He has another plane he's helping out at 6,345. 345 and out 6. If I were to draw that, He has one that's 6 away from him and one that's 5 away from him. He wants to know how far apart those two planes are. Well, what is the angle between them if one is at 310 and one is at 345, guys? 35. Can I use Pythagorean theorem? I don't have an idea that I know about. So I can't, yeah, I can't use I can't use Pythagorean theorem, but I can use law of cosines. Now, law of cosines would say x squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of 35. Look what the book did. They made that into a formula. R1 squared plus R2 squared minus 2R1 times R2 times the cosine of theta 2 minus theta 1. And then square root. It's the law of cosines. I'm not going to give you this crazy business formula because it's just the law of cosines, and the law of cosines is already on your blue sheet, yes? Okay. So if we did law of cosines for the air traffic, they're 3.4 miles apart. Okay? I'm going with their miles apart because I don't want to know their inches apart. Okay? I want to be on a plane 3.4 inches from the next plane. All right. We're going to go back and try our landscaping problem, and then we're going to play with the calculator. Somehow this landscape blueprint is on polar paper. Don't know they use that for landscaping, but we're pretending, I guess. The design calls for a bench at -4, 60. So if we go around +60 and back up 4, it's out here, yes? So in my mind, that's really 6,240, or 4,240, I mean. Yeah. Right? Is that a better name for it? With a positive? Okay. The other, there's a pond. A pond at 105.1. Is 105 on our graph paper? No, but we're just going to put it. 105 is somewhere in here, and it's 1 unit out. Okay. Now, we need to find the distance between those. Can I redraw that a lot bigger? If this was at the 105 line, and it was 1 unit long. This was 4 units long at the 240 line. How far is it from 105 around to 240? 135, yes? Okay, law of cosines. I want to hear typing. Okay, in a minute, we're going to do polar graphing, and you're going to need to be in radians. Remember I said this is the quiz where you got to go back and forth and back and forth. Guess what you got to be in for this question? Degrees, right? Because that's 105 degrees. We're talking about 135. Okay. One squared plus 4 squared minus 2 times 1 times 4 times the cosine of 135, which I'm not going to push enter until I make sure I am in degrees. Did I do something wrong already? Okay, I got that number. That's x squared though, right? So then I have to square root. Anybody get 4.75? Is that a reasonable answer? My calculator was in, I'm going to tell you this, my calculator was in radians, and I did this question earlier, and I got 4.99 or 5. No, it's not. Why can't it be 5? Yeah, if you went 4 one way, in order for the third side to be 5, you'd have to go 1 exactly the opposite, right? And that's not a 180, it's a 135. Okay. So 4.75 feet is the answer to the, is someone else get 4.75? I don't remember that answer from earlier. Okay. 7.6. That's why I don't remember. I'm like, I don't remember exactly. Anyway, you got it. All right. Now, before we play with the calculator, one more thing. Right here. Remember, I said this at the beginning of the lesson. The assignment is actually on 5A worksheet because you got polar graph paper there, all right? All right. Now, go back to your calculator. Go to mode. And I want you to be in radians this time. And then go down, and we did function mode. most of the year. Then we spent a few days in polar mode, and now we're going over, or parametric mode, sorry. Now we're going over to polar mode. Now go to your y equals, and you get some crazy r's, yes? Okay, let's start with something easy like a 2. R equals 2. What should we get? Okay, try a zoom trig, and I think it'll be okay. Is anyone's not working? Okay, mine is, okay. The zoom trig does not set your theta window for you. So 0 to 2 pi is always good. If we're in radians, everybody looking up here? So it's going to go around once, okay? 0 to 2 pi. And I set my t-step to 0.1. I get the circle. Now, if you wanted to do some fun, you could do like 3 cosine 4 theta. See what happens. You get little flowers. Okay? You can do all kinds of fun stuff. I'm going to give you the reference sheet that shows you what you can do and let you play around. Let me show you one more cool one before I do. That's true. You can turn off the axes and see some cool stuff. Let me show you one more thing. 0.1 theta plus 0.5, and I'm going to go around like this. Look what I get. Okay? Now, I'm going to give you the reference sheet that shows the equation. Okay, but the equation for this one is, it's something times theta plus something, okay? You got to make it small to fit on the screen. Now, the reason mine kept going and going and going around and around and around is because I went to 100 instead of just to 2 pi. Otherwise, it would have done just a little bitty spiral, okay? If you want it to keep going. No, I'm in radians still. Okay. Okay. I'm going to turn the recording off.